A common question often asked is, how mission engineering is any different from business as usual on how we're building warfighter capabilities today. Digital engineering is already the Department of Defense's integrated approach that uses authoritative sources of systems data and digital models to support lifecycle activities from system concept through retirement. The digitally engineered environment allows for the exchange of digital artifacts from that authoritative source of truth with increased traceability and mission requirement stability. So what's the difference? Engineers think of the systems engineering process illustrated in the form of a V. Engineers maintain that no matter what engineering approach you use, you cannot skip steps in the engineering process without experiencing the consequences of your decisions later. Digital engineering methods support every step of the systems engineering process with digital modeling, simulation and analytics using authoritative data sources with increased traceability. Mission engineering does not skip any accepted systems engineering or digital engineering best practices. It recognizes their value and integrates them into an expanded vision where the mission remains preeminent. Meet the Mission Engineering M. The Mission Engineering M is composed of 4 roadmaps. The first leg of the M represents the roadmap toward defining mission requirements. This leg includes characterizing the mission and metrics, publishing the findings and development of the Mission Engineering Management Plan. The second leg of the M represents the roadmap to developing the system's hardware and software. It includes opportunities for prototyping and other best practices to secure the desired engineering design. The third leg of the M represents the roadmap to fielding the desired mission capability, and it includes continued testing, validating and verifying the system's functionality as it is manufactured and fielded. The fourth roadmap begins with sustainment, logistics, maintenance and training and leads to retirement as risk, readiness and resilience are monitored. Now let's have a closer look at the individual building blocks of the Mission Engineering M. Starting on the left leg of the M, characterizing the mission, minimizing threats to the mission, establishing risks, and developing performance metrics are all central to setting the course for the impending acquisition. The overarching mission engineering stages illustrated here can be facilitated by leading-edge visualization and virtual tools, augmented by high-end modeling, simulation and analysis technologies. Painting the best picture of the required capability is critical to creating a realistic valuation of the program. Both Department of Defense and industry leaders can literally live in the virtual model they are considering building, and thereby make the most informed decisions. Mission engineering enables Department of Defense officials to better predict the cost of the new capability and appropriately budget for it, while industry leaders will determine if the new capability fits their corporate capabilities, business model, and capture priorities. Perhaps it should be standard practice to have a comprehensive mission engineering report that details the findings of this leg of the M, and justifies the requirements business case. This report would serve as the mission requirements baseline and source of truth throughout the continuum of the program and be the catalyst for DoD budget action. As part of the mission engineering evolution, it might also be prudent to specify a mission engineering management plan, instead of a systems engineering plan, required from industry for current acquisition programs. It is envisioned that the expanded mission engineering plan would still include mandatory information in the systems engineering plan with additional sections addressing all areas illustrated on both legs of the M. Mentioned earlier, the systems engineering, V, is integral to the overarching mission engineering approach. Remember, no steps can be skipped without consequence. In this diagram, we've added a block specifying best practices during this segment of the process. Mission engineering doesn't specify any particular methodology for the design, prototyping, testing, or manufacturing of the capability. Instead, it encourages the use of best practices as a broad opportunity to use tried and true or novel concepts to manage program developments. The right side of the M represents producing and fielding the system with the full complement of training, maintenance and logistics programs, and is followed by sustainment activities all the way to retirement. During these final phases of the system's lifecycle, metrics traceable back to the digital sources of truth will monitor performance, readiness, risk and resilience of the system now subject to the effects of aging, outdated technologies or new threats. In this way, the system's capability and performance is monitored consistently from start to finish.